Okay, so we're off and running here. So welcome. We are the week of Thanksgiving now. We only got a few days this week: Monday, Tuesday, Wednesday. Thursday, obviously, going to be Thanksgiving, and you hope you uh, take that day to rest, do what you need to do. But let's start taking a look at looking ahead to um, the end of the session, and what do we got kind of here? Oh, good, we have a calendar right here. So let me move to December, and hopefully what you're going to see is I'm over here and I'm looking at the calendar over here. So the this week right here, December 2nd, 3rd, 4th, and 5th will be the last nights of instruction. Um, and as I understand it, and I'm also checking in with you all too. The this week right here, the week of the 9th, this is what we call finals week. So I'm sure you're having your final exams in other classes as well. Is that accurate? Kind of just
Um, I just have one other class, and I don't know when the final exam is
okay.
yet.
As I understand it, I don't think the final is set for a specific day. I mean, we have a 4 day a week class. I don't know if it's set for a specific day. So what I'll probably, but I have to submit, I'll tell you, I have to submit final grades by the 16th. So essentially, we need to have the final exam done before the weekend so that I have time to look through everything and make any needed corrections or updates, both in this and the next class. So, what I'll probably do is look to have you all complete the final exam on one of these 4 days. Now, I'll get more guidance from my administrator, but I think that's kind of the way it's supposed to work. So that because I don't know if there's a set specific time that we do this, just like the tests. Um, but it's been a while, so I don't have all the complete answers. So, but nonetheless, you should expect your final exams at some point in that week, 9th, 10th, 11th, or 12th, and that means that what we've got going on tonight, we have one, two, three, including tonight, 7 days of instruction, if you will, instruction and review. So we're not going to have another test, another regular test. The next exam is going to be the final exam. But you can pretty much sort of, I hope you're seeing that the material we're working on pretty much operates as a final because you have to reach back all the time for the information that we've done in the past. So in a way, what we're doing is largely review of prior material. But if you have any questions, certainly ask them. On that note, you should be having an eye now towards let me scroll down this list. You should be looking at your assignments, looking at your grade book, looking at the assignments. Where do you have gaps? Where do you have gaps and everything? And so hopefully at this point you are completed through what? Oh, hopefully at this point, yeah. So hopefully at this point you're completed through, this material because we had a test on it, one, but then two, the due date for it was last week, but then three, it's a good time to be caught up for sure because now we have quite a lot of lessons to work through from this point forward that you just don't want to fall. No need to fall behind on it. But it's one of those things also always keep in mind, if you have a couple, let's say it this way, we get to the end of the session. If I were a student, I get to the end of the session and I'm looking at this stuff down here and I'm like, I'm just not going to get to it. Okay, 4 lessons is not the worst thing in the world. To if it comes down to it or so, or 5 or 6 or something like that, you've had dozens. You've had like 40 lessons. So so a handful of them are not going to make or break your grade. And on the final exam, candidly, you may get one, maybe two questions that cover this material. So it's not the worst thing in the world. But kind of looking back though, you do want to make sure you have everything through this, through 4.4 for sure to be done because this stuff down here, a lot of it is just review of prior stuff. So it is doable for you. It's just, you got to learn how to package it together. This stuff up here is new and we need to learn how to do it. So I'm not saying don't do anything. What I'm saying is if there's a couple lessons by the end that you just don't get to, don't stress out about it. It's not going to make or break your grade. Because overall, what I'm seeing in the course is most everyone is doing very well. But it is time to start taking stock of where you're at, the time we have remaining, and get it all done. And so when I go back to the calendar, then when I go back to the calendar, we'll pick the day when the final is, but that sort of gives you that these couple days here, the 9th, 10th, 11th, and 12th of December, it gives you those couple days there to finish anything you need to finish as well. So that's the cool thing about the whole thing. So let me pause here briefly. Any questions about the calendar? Kind of what we need to get done, what needs to be done in the final what 2.5 weeks. Okay, don't hesitate. Let me check the chat up. No, let me see. Okay, Jana. Yeah, sorry about that. Jana, I'm seeing your note, and I think another student's experiencing the same thing. Have you all ever contacted tech support as to why you can't see anything or hear anything? Okay, I'll just throw it in there. Yeah, no, I just realized that too, Adam. That's why I typed it into the chat. uh, okay, well, the hope is also, Adam, that when they go back and listen to the recording, that they'll maybe respond to me separately by email. Okay, so any burning questions that I need to address before I move on? What you
Um,
got, Addie?
there'd be like a few minutes for just asking questions, like for review,
What you got?
or yeah, well, fractions.
Okay, what aspect?
Um, I don't know. Sometimes I just don't really know where to begin. But there's one that came up. Okay, so there were complex fractions that I was working on. I didn't really understand it until I like looked at the tutor when I was on the practice session. And it made a little bit more sense. It's just I needed to take my time with it. But then there's one that came up about like rates. It was more like a word problem, I guess. But it
Okay.
was APY equals, and in parentheses, 1 plus R over 2, close parentheses, squared minus 1. And I looked at it step by step, and it made no sense to me.
Do you remember what lesson that was in?
I think it is 4.R.9 or 4.R.7.
Okay.
Simplifying complex fraction.
I don't see this being a very heavy emphasis on the final, FYI.
Okay, great. Okay, well, don't worry about
Oh, no, no.
it then.
Let's see. Ah, this one. The average
Yes.
percentage yield of an annuity is the annual interest rate earned in a given year that accounts for the effects of compounding, right? The APY acts as the interest rate for a simple interest account and is larger than the stated interest rate of a compound interest account. The formula to calculate the APY for an annuity after 2 years is the following. Simplify the expression for APY and write it as a single rational expression.
Even reading the word problem, it seems like a different language.
I think what they want you to do
That's
is
crazy.
they want you to take this thing and write it as one fraction, one denominator over one numerator.
Okay.
Okay, so what we have here is we have a fraction here, and three separate expressions. They want you to they want you to combine everything together. So what I would do, so this one you have to, whoops, no, this one you have to resolve the squared first. Remember, and that's the FOIL method.
Right.
Okay. So the very first thing is, so this becomes 1 plus r over
That's where I got confused.
r squared over 4.
I was confused where the extra r came from, 1 plus r. So I understand that you would square the 1 and then square the r over 2, to get r squared over 4. I just wasn't quite, I didn't understand where the extra r came from.
So FOIL is the first. That's 1 times 1. O, that's the outer. That's 1 times r over 2. I is, oops, yeah, r over 2 times 1, hit enter, and then L is r over 2 times r over 2. So when we do this, then, oops, sorry, this right here gives us 1. This right here gives us what? R over 2. Do you see that?
Yeah.
This one is also r over 2. And then this one is r squared over 4. Do you see how we get the individual products for FOIL?
Yes.
Okay, so we bring that together. 1 plus r over 2 plus r over 2 plus r squared over 4. We add it all together, right?
Uh-huh.
Yes, no?
Yeah.
Okay.
Yes.
So when you combine r over 2 plus r over 2, that gives you what? Remember, this is 1r plus 1r over 2. So you're adding fractions.
Uh-huh.
Oh, no words. Let me write it again. 1 plus r over 2 plus r over 2 plus r squared over 4. Okay, so let's write it as a fraction. R over 2 plus r over 2. When you're adding fractions, remember you're just adding the numerators. So that's 2r over 2. The 2's cancel to leave
Oh,
1r.
okay.
That's where we get that guy.
Thank you. Yeah, that makes a lot more sense. Thank you. Yeah, just the tutor didn't really work that out. So I was just
Okay.
kind of,
So then to
thank you.
combine this all, you put everything over, you have the common denominator of 4. Oh, that's funny. We don't have to wait. I'm not going to do that yet. This minus 1 right here and this 1 right here are going to cancel with each other. Leaving the middle part right here. So let's pop it over here. Now we turn that into one expression. So it's 4r over 4 plus r squared over 4. Now we can combine those fractions, and that gives us, for the answer, 4r plus r squared, all of that over 4. That's the overall answer for that one. This
Okay.
thing right here turns into this thing right there.
Right. Okay. I think I may have missed something when you did. Okay. So the last place I left off was r plus r squared over 4 because the ones canceled out. That
Hmm.
makes sense.
So
And yeah.
that's this right here.
Mhm.
So what you have to do is get common denominators. And remember that's, well, let me do it this way. Remember r is really a fraction over 1. So we have to multiply the top and bottom. We have to get common denominators. So the way that we do that is we multiply the top and bottom by 4. And that's how we get this thing right here.
Hmm.
I wish I could have done it a little more linear. Let's follow along. I'm bouncing around on the page here. I apologize about that.
No, it's a lot better than the the tutor,
Okay.
the Hawks tutor. Okay, thank you.
Oh, I
I
see.
appreciate it.
The tutor and Hawks. Yeah, sometimes they do leave gaps. You're right.
Yeah, no, tutoring in person helps when I can go, but the Hawks,
Yeah.
rough.
And just to kind of follow up with every, when you have those instances, take a screenshot and you can say, hey, if you, how do they get that R? Can you show me that? I'm happy
Okay,
to do that.
good. Thank you. Thank you. I will. Okay.
Okay. Anybody else? Any other questions before we get going? Okay. Well, let's keep pushing forward. And oh, did I miss anybody?
Mhm.
So yeah, just keep your questions coming, and if there's more that come up through our time tonight, certainly jump in. Happy to help
No,
out.
I have a question right now. Can you
Yeah,
hear me?
I can hear you. Yes.
Okay, so whenever did everybody take their test? I just have one question.
Hmm.
Do y'all know if they did or not? Well, on one of the questions,
I
I
do
know
not
the
know. Let
answer.
me say it that way. I
Yeah,
assume they
no,
did.
you don't.
We,
No, they didn't take all their tests yet.
I think there's still one or two hanging out, but that's not a you problem. That's I got to follow up with them issue. What you got? I'll
Okay,
answer as
so
best I can.
I took mine last night, and I was having a problem with the graph. So I know it was vertical to 0, but it wouldn't allow me to do that one. It wouldn't let me move it. It wouldn't let me do anything.
Remember the
Um,
question number?
it's towards the end. I think it was question number 8, and I know the answer was 2 0, a vertical line, but I wasn't able to do it, and that was the only question that I missed.
8. Was it this one?
No, it was a graph. Maybe it was a no.
This one?
Uh, yeah, but why you got 4?
Say it again.
Isn't it 2 0?
Isn't what 2-0?
The answer, well, I feel like the answer was 2 0, whichever graph it was. I only had one graph on mine. On my test. But it was supposed to be vertical up and down, and I believe the answer was 2 comma 0. I think it was the one you got, but I don't know why you have a box. I think it's that one, but I'm just unsure why you have a box. Oh no, that's not it.
Graph.
Maybe answer 9 or 10A,
No, it wasn't either one of those.
because we only had one on the test that was answer that was a graph.
Do you know what shape it was? Was it an oval or?
It was no shape. We had to graph it. Like we had to put it on the graphic. Y'all remember?
Mhm.
That one. I think it was 2 comma 0 vertical.
I didn't even see this one really. 2 comma
And it
0.
would, yeah, that's the answer I think it is. And it was a vertical line, but it did not let me move anything. And if it when it did let me move it over, it moved it all the way to the end. See, it didn't let me do any of that. And
Uh,
that's why I have like a lot of incomplete. I have like maybe 7, and they're all on graphs because it's not letting me do. It's like I don't know, maybe it's my mouse or something. I can try another device or maybe my work computer, but it's
could
not
be.
letting me move the graphs.
This is the only one that I had a graphing question on.
Yeah. So
But
I'm asking, it was the answer 2 0?
no.
No. Okay. So either way, it would have been wrong.
But
Okay.
this is the only one that I had a graph that you had to graph. So maybe you're talking about a different assignment.
Mm-mm. It was a test. I took a test last night.
The others, none of them require graphing.
Yeah. But I was talking about the other assignments too, like the assignments that's due.
You want
I
to
have like
check your web
seven.
what web browser are you using? Like Chrome or
Uh,
I don't know,
I think
Firefox?
I'm using Chrome. No, I'm using. I'm on a MacBook. I'm using Safari.
Maybe try Chrome or Fire. I'm on a MacBook too, and I'm using Firefox.
Okay, so maybe I need because it's not letting me do the graphs, and the ones that's not completed for me, they're all graphs. I just wanted to let you know that before.
Well, you need to get that fixed because it is. I mean, the tests are on. You need to address that. Uh, it's going to adversely impact you because there is going to be graphing. There's graphing here. You want to be able to plot the points. Fortunately, that I mean there are a few. Like one of those assignments requires you to graph extensively. Like not many, but there's some.
I know,
So it's not like a lot of homework and a lot of questions, but it will have an impact.
I know, and that's what it's doing right now because I went
So
from literally a
why don't you
100A to like a C now.
why don't you download Firefox?
Okay.
That's what I'm using. It works. Sometimes restart your computer. There could
Hmm.
be something going on, and make sure also when you're going to so restart your computer.
Hmm.
There could be some gremlins in your web browser that are causing conflict. Uh, where is it? Oh, look at
And
this.
it's only the graphing, like it won't let me move it, and if it does move it, and move it where it wants to go, like it'll keep it as a straight line, or it'll keep it.
So so restart your computer. There could be some conflict. Use a different web browser, like Firefox is pretty
Mhm.
neutral. Um, if that still doesn't work, you're gonna have to get tech support involved. And
Okay,
you may
or
want
I'll
to.
just use my work computer. I'm not supposed to,
Oh,
but do it.
well, there's that.
Yeah.
But I would do tech support for Hawks because they can
Okay.
probably get you what you need.
Okay. Thank you.
All right. Okay, let's push forward. Let's see what we got. Okay, so these two here, combining functions and then inverse, it's a fun lesson, in my opinion. Combining functions, and I'll give you a preview of what we're going to do. When we say combine functions, it means we're taking our basic operations, add, subtract, multiply, divide, and we're treating functions as numbers. And we're seeing how do we add functions, how do we subtract functions, how do we multiply functions, and how do we divide functions. I'm going to tell you the short answer here is it's no different than what you've been doing already. And what you're going to end up finding is that for the most part, adding, subtracting, multiplying, dividing is just using your skills from the past of adding polynomials, subtracting polynomials, multiplying polynomials, and then dividing polynomials. And remember what we did? When we divided polynomials, that's rational expressions, factoring. So essentially what we're doing is we're taking two different functions, combining them together by using an operation to create a wholly new kind of function. Just like we take the numbers 2 plus 3, add them to get a new number of 5, we're doing the same thing with functions. F of x plus g of x, add it together to create a new function. We're creating functions by combining them. Now, there is a fifth operation that we're going to learn that's unique to functions. It's a new one, but it's not. It's actually something you've already done before. You just don't realize you've done it. Uh, okay, so let's talk about this. So at the end of the day, all we're doing most of the time, what we're doing is adding, subtracting, multiplying, dividing. Okay, so let's see. And here we go. So what do we got going on here? So it says use the values f of negative 2 is negative 2 and g of negative 2 is 4. Using those results, find f plus g of negative 2. Okay, so before we start doing this, let's sort of diagnose what we got. Is we're telling you some information about the f function, that when you plug in negative 2, when you input the value of negative 2, you get an output value of -2 as well. And we're telling you some information about the g function. When we input the value of -2, we're going to get an output value of 4. So this is just a regular f and g function like we've been working with. Over here, it's telling you we want to create a new function, f plus g. And how do we do this? Well, we combine the two functions f and g, f and g. Now, what we're telling you is we want to plug in the same input value into both. We want to add the two functions at a similar. So essentially, what happens is for every input value, f of 2 or f of -2 and g of -2, we're going to add those points and it'll create the output for that new function. So essentially what we do is you just take f of -2 and you add it to g of -2. So essentially, it's not distributing, but what we're saying is that -2 is the input value. So to find the input of the function created by the sum, input the value into each individual function and then add the results together, add the outputs together. So essentially, when you're adding two functions, take the input value and plug it into the input of the f and g function. So then, what is f of -2? Well, they tell us right there. F of -2, the output is -2 plus. What's g of -2? Well, they tell us right there. It's 4. So the result is, oops, almost got it wrong. The result is what? 2. Yeah, 2. So the result here is the value of 2. Basically, we're adding two functions, f and g. We're inputting the value of -2 into that sum function, and we'll pop out a value of 2. But the way that mechanically you do it is you just take this input value of -2 and plug it into the f and g function. So any questions on that? Let me back up. Lost on mine. So let me do another one. That's actually be helpful. I didn't mean to do that. Oh well. This one's fine to do too. So what is this saying right here? So you have two functions right here, the f function and the g function. They're telling you what the ordered pairs are for each function. Okay, that they're giving you the function in ordered pair format. So using this information here about f and g, they want you to find f plus g of 1. So this translates into plug 1 into the f function, add it to whatever you get when you plug 1 into the g function. So let me throw it to you. Based upon this information up here, what is f of 1 reduced to? What is it? What's the output for f of 1? When 1 is the input, what is the out? When 1 is the input, what is the output from the f function? How do you find it? Remember, you're dealing with ordered pairs. And ordered pairs are of the format x comma y. Which value, x or y, is the input?
X.
X is the input, comma, output. Think of it that way. I/O, input, output, input, output. So go to the f function, scan it and find the value of 1. There's your input. That's the corresponding output, is -1. Do y'all see that?
Um, I'm sorry. I think whenever you were talking, I was still writing down everything. Sorry, just kind of missed.
So much of this is review. Much of this problem is review. So just
Yeah.
keep in mind, remember, functions are all about our factories, inputs and outputs, okay? You input something into a function, into a factory, it processes it, and it spits something out, the final product, okay? There are different ways we can express functions. One way is like we did here, in ordered pair format. And you just have to refresh your memory and say, oh, when it's an ordered pair, it's of the format x comma y. And when I'm dealing with an ordered pair, the x is always the input and the y value is the output of that function for that value. So now we look to the problem, f of 1. That's saying 1 is the input. So scan the ordered pairs to find the input value, the x value of 1, and then look for the pair, the y value associated with it. And so that's where we get -1 because that's the y value, the output value associated with the input value 1. With that in mind, what's g of 1? Oops, what's g of 1?
Is it 4?
So find 1. Yep, there's the input, and that's the output associated with it. Yes, it is 4. And so when we add the two results together, we get 3. So to find the sum at 1, you plug in 1 into the f and g function and add those outputs together. And so the final answer is 3. Oh, let's do it again. Okay, you answer this one. What's the answer?
Can you hear me?
I can hear you, yes. Hey.
I'm on my mobile device right now. It's working. Keep fingers crossed. Would it be would it be 1?
Final answer 1? Is that what you're
Yeah,
saying?
3 would be the input and 1 would be the output.
So
Oh,
we input 3 into both the f and the g function.
okay.
So when I plug 3 into the f function, what's the output for that?
Okay, -2.
Right,
Did I
-2.
see the answer?
And
I
so when I
don't.
plug 3 into the g function, what's
It would
the
be
output for that?
1.
1 right there.
Okay.
And now I add the two together. -2 plus 1 gives me -1.
-1. All right.
So take the input of 3 and put it into both f and g. The outputs of those, you add them together, and that gives you the output of the overall function. So we're creating this new function f and f plus g. But the way that you find it is you individually just keep working with f and g as you normally would.
Okay.
Questions on this one? Okay. Excuse me. We're good to go? Okay. Okay, so they're going to do it again. They're going to do it again. So now what they want you to do, they've given you a function, f of x is equal to 4x. They're giving you the formula for the function. And g of x is equal to the function, or is the function x squared minus 4. And what they want you to do is using those two functions, find the addition of add those two functions together. Add those two functions together. So just like before, we're going to take the input here and plug it into both f and g. So this becomes f of x plus g of x. What is f of x?
Four x.
4x. Bring down the plus sign.
Would it be x squared after
What's g of x?
squared? X squared?
All of it. X squared minus 4.
X squared. Sorry, my kid was talking.
So now we add them together. Can we add? So when we're here now, so questions on this. How are we doing here? Do you see how we get this line right here? All we did is just, we said, well, x is our input. And so we wrote it as f of x plus g of x. And then we just replaced f of x with the formula. The output is 4x. The formula is the output. And then same thing for g of x. The formula is the output, x squared minus 4. Let me pause. Any questions on how we got to this line right here? Because now
Maybe just drag the -4 down because I know I did. I know it's x squared, so you just bring the -4 down with it, right?
well, but this is the reason why is because we're looking for this expression here says I want g of x. So g of x is equal to the entire thing, x squared minus 4.
Okay.
Not just x squared. The entire thing. That is the formula for it. This is the factory. It's the expression that creates the function.
Okay, and then the domain, would it be?
Well, hold on. We're not there yet. Hold on. We're not there yet. When you get to this line, we happen to be done here. There's nothing more to do. But you want to look for, can I combine like terms? Combine like terms. Can I combine like terms here?
No.
There are no like terms. So the way that you write it is you write it from the highest exponent down. So we write the x squared first plus 4x minus 4. We combine those two functions to create a wholly new formula, new function. So when you're adding, so
You have written it the way you
point,
just had it written?
say it again.
Could you have written it 4x plus x squared minus 4, or you have to write it x squared plus 4x minus 4?
There probably would count it wrong if you did not write it like this.
Okay.
Technically, you could write it the other way. Technically, yes, it's the same thing. But the way that we write functions, we write it using the highest exponent first, the term with the highest exponent, and then the next highest exponent, the next highest exponent, all the way down to you get to the constant term. So that's why x squared goes first and then the 4x, because it's exponent of 2, then exponent of 1 over the x. So essentially, when it comes to adding functions, when it's f of x plus g of x, all you're doing is you're adding polynomials. You're combining like terms in a nutshell. Now the domain. You're asking yourself, what's the domain of this thing? And remember, just from last week what we did. You start off with everything, all real numbers, and see if there are any values that should not be there. So what are we looking for? We don't like values that make denominator 0. We don't like values that make square roots negative. So those are the things you have to look for. Start off with all real numbers. And is there anything we have to throw out? Is there a fraction? Is there a variable in the denominator? Nope, so we don't have to worry about that. Do we have a square root? We don't have that, so that's it. So it's all real numbers. All real numbers. So when you're asked the domain, when you're given the formula, here, when you're given a formula, you start off with the real numbers and then chip away, exclude. Exclude values that will make a denominator 0, exclude values that will make the square root negative. That's the way you approach. When you have the formula, that's the way you want to approach it. Do another one. Excellent. So we want to add the two functions together. Add the two functions together. So it's f of x plus g of x. F of x plus g of x. F of x is that square root of x minus 4. And g of x is what? X squared minus 1. So we come over here. X squared minus square root of x minus 4. Well, let me actually type it for you so you can see using the keys, the features. So I'll use the keypad. Oops. I'll use the keypad. So x squared plus the square root. Where's the square root? Ah, there you are. Square root of x minus 4. Make sure you hit your right arrow to get out of it. And then minus 1. This minus 1 right here has got to be outside of that square root. One or two of you all sent me a question about that. Some of y'all were doing this. You got to hit the right arrow. You have to hit the right arrow to get out of it. Okay, domain time. Domain time. Looking at our function here, you start off with all real numbers, okay? And throw out anything that should not be in there, any problem numbers. Do we have a variable in the denominator? Yes or no? No. Do we have a variable inside of a square root? Problem, problem, problem. Throw out, find the value. We need to know what values make it negative. What values are going to make this thing negative? Because we can't have that. We need to throw them out. So take the inside. See which ones are negative. And so what values make it negative? Any value less than 4. Those are the numbers we throw out. So what do we keep? The opposite. We keep the opposite. So what's the opposite? What are values that are less than 4? 3, 2, 1, 0, all the way down. Keep going. So what's the opposite? Values that are larger than 4. Just flip it around. The question is 4 itself? Is 4, do we keep 4 or do we exclude 4? Which one? If I plug in 4 for x, is that a problem?
Yes.
If I plug in 4 for x, so let's see. If I plug in 4 for x, it makes the inside of the square root become 0. What's the square root of 0?
0.
So it works. We can keep it. We can keep it. So the domain is any value greater than or equal to 4. So the point, the exercise is this. When you have a square root, like here, to find the domain, take the value, take the expression, and find when it's greater than or equal to 0. That's what the domain is going to be. When you have an expression with the square root, find the values that make it greater than or equal to 0. And those values are all values greater than or equal to 4.
Okay.
Yeah, go ahead. So that's the domain.
Yeah. Maybe I just need a refresh on what exactly is the domain? I guess before now, I've always thought of the domain as just the X value in a set of
So
ordered data.
the domain is all possible values that work, all possible input values.
Okay.
And so you essentially ask yourself, well, what could work? What values could work in this thing?
Okay. That doesn't allow it to be, like you said, negative in a square root or.
Right. Anything works. So it's basically the domain is anything that works. So if we look at it, if we kind of hone in, well, there's no value. This term here, the x squared term, that's not a problem. Every value is going to work in the x squared term. So that's not a problem. The problem comes here. This is where the problem is. There's some values that do work, there's some values that don't work. And we want to only keep the ones that do work. So if anything works here, anything works in the x squared. So if it works here, it's definitely going to work here. So we don't have to worry about the x squared. It's always going to work. Our problem and what we have to really satisfy is this guy right here. That's the guy that's going to kill it for us. So we have to ask her, so it really hones down to say, what values make this thing work? And we need this inside value expression to be something that is either 0 or higher than it. The only ones that work is if it's 0 or positive. 0 or higher than that. That's why we're using a greater than or equal to symbol. And that's going to tell us the values that do work. So long as it's a value that is greater than 4, greater than or equal to 4, it'll be A-OK in here. It'll be A-OK. And that's what means, that's the domain. That's the domain. So let's see what we got. I wonder how they want us to write it. Doesn't want us to write it that way. So we have to write it probably in interval notation. Interval notation. So any value higher than 4, so that's going to be all the way up to infinity, or equal to it. So I bet you that's how they want it. Yep, that's how they want it. Interval notation. Oops. So you have to pick the right one. That's the one. Submit answer. Boom, you got it.
Okay, so it bracket.
So they want you to write the domain in interval notation. So the domain is x is greater than or equal to 4, but you write it in interval notation as that. So all we're doing here, we're really not doing anything new, just to keep you kind of step back from all this. To add two functions together, to add functions just means take the individual functions and add them together, combine like terms. That's all it is. It's still working with the old stuff. Take your input, put it into both functions, find the respective outputs, and add those outputs together. So really, to add functions is just to work with the individual functions and add the outputs together. That's it. Finding the domain of the addition function is the same thing as finding the domain of the original functions. That's all it is. From prior weeks. Excuse me. So let's push forward because there are other things we have to do. This one here is saying, what did it do? It's dividing f and g. It's created a fraction between f and g. Okay, so we take the x and we say f of x divided by g of x. So you create a fraction. You create a fraction. Well, what is f of x? It's the square root of 4, x minus 4. So that becomes your numerator. It's a simple replacement, just like last time. So this becomes, so I'll type it here. So we need a fraction. Where's our fraction? Here we go. In the numerator is that f function. And in the denominator is the g function. Oops. So to divide two functions is just to do f of x over g of x. So now the domain question becomes a little more interesting on this one. You still have to throw out what values what values work. We need to know what values work. So what values work here? We can't have, we still can't have negatives and square roots, negative and square roots. So we still can only have those values. They're still going to be greater than or equal to 4, right? In order to make that work. Yes or no? Yes. What else is problematic? This down here. Now we have a variable in the denominator. So what values will make the denominator 0? 1 or, so remember, take the denominator, set it equal to 0, and solve for x. So we're going to use the square root method. Take the square root of each side. And when you take the square root, plus or minus. So we get x is plus or minus 1. So what values make the denominator 0? 1 or negative 1. Either 1 or negative 1 will make the denominator 0.
Wouldn't -1, so it'd be -1 minus 1. That wouldn't be -2.
So let's plug in negative 1. I want to come over here and change my coloring.
Oh, -1 squared.
Negative 1 squared becomes
Give
what?
you one.
Positive 1. Right.
Okay.
Right. So just keep in mind, for the numerator, we need to have values that square root's causing us a problem. Our x's can only be values that are greater than or equal to 4. Okay? This part of the analysis over here focuses on the denominator, what values will make it problematic. So we don't want 1s or negative 1s. We can have any other value, just not 1 or negative 1. Those are the only two values that will make the denominator 0. So now put the two domains together. On the numerator, we need values that are only 4 or higher. Does that create a problem with our denominator? Our denominator says any value that is not 1 or negative 1. Well, guess what? If you're 4 or higher, 1 or negative 1 is not even a problem for you. You don't have to worry about it. So essentially, this thing here, x is greater than or equal to 4, actually is the domain because it already takes care of and eliminates the two values. It eliminates and excludes the two values that create a problem for a denominator. It just so happened to work out that way. So the overall domain is this right here, meaning this is still the same domain. So what you want is a set of all possible values, the things that won't make this thing a problem. So the numerator, you analyze it separately, the numerator and denominator. What things will work, what things won't work. You want to identify what things won't work and throw them out. Or focus on the things that do work, is kind of another way to say it. Okay, let's keep pushing forward because we got more. Okay, now this is the one we needed to get to. Okay. So when you add, subtract, kind of, let me go to a whiteboard here. Stop. Share. Okay. So I'm going to do f of x equals 2x minus 1, and g of x is 5x squared plus 3. I'm just making stuff up. So there's 4 operations. You've seen it already. We can add, we can subtract, we can multiply, and we can divide. Okay? So suppose I wanted to do we've already done f plus g, so I'm not going to belabor that one. But suppose I had f plus g of 0. How would I do that one? Or I'm sorry, f minus g. This is f minus g. How would I do f minus g of 0? I do it the exact same way that I did, but let's do them all. Let's just plug in 0 for all of them. Okay. So f plus g of 0 is what? F of 0, just take the 0 and plug it into the f and the g function, right? Yes, no, maybe so. You take the input and you plug it into each individual function. So now calculate g of 0, or f of 0 and g of 0. So f of 0 is 2 times 0 times minus 1, which is negative 1. And g of 0 is 5 times 0 squared plus 3, which is what? Anybody see it? 0 to the second power is 0. 5 times 0, still 0. 0 plus 3, 3. So take the 0 and plug it into the function f and g, and then add the results together. So that's what? Negative 1 plus 3. And what's negative 1 plus 3? 2. All we're doing when we're adding functions, you take the input and plug it into the 2 functions individually, see what those outputs are, and add the 2 outputs together. So we're plugging 0 into the f and the g function. We found those 2 outputs, and we add the outputs together. So using our result, same process. F minus g of 0. Take the 0, plug it into the f and the g function, but subtract, okay? Then what? Well, what's f of 0? Now plug in 0 into the f function, and we get negative 1, minus, plus 0, plug 0 into the g function, and get the 3. And so when we do the subtraction, we get negative 4. Let me do this. Do you see what I'm doing here? Or any questions on what I'm doing?
Yes. So when you have, let's maybe focus on that f minus g, f of 0 minus g of 0. Would you plug in 0? You plugged in 0 for x, right? So like
That's the
2x
input,
minus
right?
1.
0, what we're indicating here is 0 is the input.
Okay,
Right.
yeah.
You're replacing x with 0, right?
Okay. think I've got it now. I just skipped the whole step.
So it doesn't matter what the operation is. Fundamentally, you take the input and plug it into the individual functions. So how would I do f times 0? F times g of 0. Plug in 0 for f and multiply it to g of 0. Because that's the operation we're doing. We're doing multiplication here. So f of 0, go back to what we calculated up there. F of 0 is -1 times g of 0 is 3. Do the multiplication, and we get -3 for the answer. F divided by 0, f divided by g of 0, same thing. Plug in 0 into the f and the g function and divide the result. So plug in 0 so it becomes f of 0 divided by g of 0. Make the replacements. F of 0 is that -1 we found. G of 0 is the 3 we found. And so this actually happens to be the answer, -1/3. Your turn. I'm gonna keep the same thing. Keep the same thing, same function, and I'm still gonna use f of 0 and all that stuff. Your turn. I want you to do this. G times f of 0. Notice all I did was switch the order of multiplication around. But don't worry about that. I want you to do this one as we've been doing it. How would we do this one? G of times f of 0.
So you'd of course plug in 0 for x. So it would be 2 times 0 minus 1 times 5 times 0 squared
So
plus.
let's first take the 0 and we're going to plug it into the g function and to the f function. Oops. Right, that's essentially what you're saying, Addie.
Oh, okay.
Take 0 and plug it into the f and the g function. And whatever you get when you do that, you're going to multiply the results together. So take 0, plug it into f and g, see what they give you as the outputs, and multiply those two outputs together. So what's the output when I plug 0 in for g?
The output. Oh, okay. I think I see what you're saying.
When I put 0 in for x, I'm using input output. Remember, input means x. So
Yeah,
when I put 0 in for x, what's
right.
the output of the function? Excuse me.
So 2 times 0 is 1. I'm sorry. 2 times 0 is 0. So 0 minus 1 is -1.
That's for which function?
F.
F or G?
F.
F.
Oh, I can do G first. I'm sorry.
That's fine. You can do either one.
Okay, great. And for G, you first would square the 0, right? Because in the order of PEMDAS. So just, yeah. Anyway, 5 times 0 is 0. 0 plus 3 is 3.
3. So I got 3 and -1. And now I multiply those results to get -3. So this is the answer. For this thing right here, I plug in 0 into both f and g, multiply the results that I get. That's the answer. That's the way this thing reads.
Yeah, okay.
So let me change it up. Now I'm going to do g divided by f, all of that, of 0. we do take 0, you still plug it into f and g. Now get your results. What's g of 0?
Um,
Remember, we did it up here.
oh, okay. -3.
Not -3,
Oh,
+3. G of 0 is +3.
right. Okay. Yeah. So 3 over -1.
Over -1. And the overall result then becomes what?
-3.
The -3 is the final answer in this case. So when you're dealing with functions and you want to add, subtract, multiply, or divide, all you do is you take the input function, replace it in for x, into the individual functions, work with them individually to find their outputs, and you add, subtract, multiply, divide the outputs. That's all this is really saying. We're not doing anything new for you. We're taking two functions and working with them at the same time. But I do want you to observe the order matters. G over F is G is in the numerator, F is in the denominator. On the other hand, look what happened. When I had F in the numerator and G in the denominator, it was a completely different answer. So you got to make sure that you go in the right order, the order that is listed.
So how do you know which way to go?
Always. This one's in the top, so G of 0 is going to be in the top.
Oh, right. Okay.
Maintain the order, yeah.
So it'll give you like
It'll
this
give
one.
it to you.
Okay.
It'll give it to you.
Yeah, because I noticed like for all the other ones, the F went first. But
And that's why I wanted to do this, because we don't have to do F first. We can do G first.
Okay. Awesome.
And I'm setting you up for something, what we're going to do right now. So let me take this, and I'll take these down here, and I'm going to go to a new page. There we go. So let's go to a new page. I'm going to do a completely new and different operation. So we still have, I'm going to go ahead and just simplify this, just to let us know. We know what those values are now. There's a new and unique operation to functions that you have never seen before. It is called the composition function. The composition operation. This is when you plug a function as an input to another function. This is when the function becomes an input to another function. And the way that it looks, the composition function looks like this. F, open circle, G. Looks like fog. Okay? Well, let me not do X. Let me do 0. It looks like fog, doesn't it? It's a little open circle, not a closed circle. Closed circle means multiply. Open circle. This is how you know you're dealing with the composition operation. And what it's telling you, well, here's the translation. So let me do this. Well, it says, the way that you translate it is this. The first function is the outer function. The second one is the inner function. And then you put 0 inside of it. So it looks like this. And we'll write a little more cleanly. I'll write it like that. I'll write it a little more cleanly. F, open parentheses, G, open parentheses, of 0, 2 parentheses. The 0, and here's the way it's going to work, and I'll show you how it's done. You take the 0, you plug it into the G function. Find the output from the G function. The output from the G function becomes the input to the F function. It's weird. It's weird. Okay, so, oops. So we do f of g, it's red, f of g of x, or 0 in this case. F of g of 0. And what this is telling you, take 0 and plug it into g first. What does that give us? So wait to do f. Wait to do f. Don't do anything with it. Wait. Just find the inside part, g of 0. And what is g of 0? 3. Yeah, we have it right here. G of 0. We've been using that one the entire time. So the output of g of 0 is 3. That becomes the input to the f function. That becomes the input to the f function. So now we go and find f of 3. So take your f function now, plug in 3 for the x. Two times 3 minus 1, and that equals what? 5. That's the answer in this particular problem. So composition is the function is plugged into another one. The output of one function is plugged as the input of the other function. The output of one function is plugged in as the input of the other function. Say it just like that. Talk to yourself. The output of one function is plugged in as the input of the other function. Okay? How do you know which one to do? The first one that's written, f, is the outer function. The second one that's written is always the inner function. So the output of one function is the input of the other function. The output of the inner function is the input of the outer function. So let's see it again. And I'll change this. When you plug an output of a function as the input into the other function. So let's see this. So this time I'm going to switch it up. I'm going to do g composed with f of 0. So we translate this. G is the outer function. G is the outer function. F is the inner function because it's written second. And we plug in 0 in that. So evaluate f of 0 first. Evaluate f of 0 first. And what is f of 0? -1. So the -1 is the output of the f function. It becomes the input of the g function. And so now we input that into our g function. Everywhere we see an x, plug in -1. And simplify. So the final answer to the whole thing is 8. So you plug it in, so you work inside out. Inside out. Plug your value into the inner function, get that value, and plug it into the second outer function. So let's do a wholly new one. We're going to keep the same two functions, but now I'm just going to sort of erase those. So suppose you were asked to do f composed with g of, I don't know, -4. Take a moment. Out. You don't have to finish the whole thing. I'm gonna give you I want you to get started on it. So we translate this. I'll get started. F is the first function, it's the outer function. Parentheses. G is the second function, it's the inner function. Plug in -4, parentheses, parentheses. So we need to first plug in -4 into the G function. Okay? So that's scratch sheet of paper time. Come off to the side, plug in -4. What does that give you? Well, so what do we get? G of -4 is what? 5 times -4 squared plus 3. What y'all get for G of -4?
23.
I think it's more than that. -4 squared is 16. 5 times 16 is 80? Yeah. And then G of -4 is 83. So this is what G of -4 is. When I plug 4 into the G function, I get 83. Let me check. 5 times 16. Yes, 80. Do y'all see how I did that? Wherever you see an X, plug in -4 and simplify the right side. So this 83, G of 4 is 83, so we plug in 83 here. So it becomes F of 83. Okay? So the output from the G function becomes the input to the F function. So how are we going to find that? So go to the F function now. That's 2x minus 1. Plug in 83. Is that 166? So the final answer is 165. So F of G of -4, the final answer here is 165. It's the overall thing. So we plugged in -4 in for G, found its output of 83. That output of G became the input to the F function. That's how this works. Cool thing is, you're going to get another chance at this, because we're going to switch the order. G composed with F of -4. Quick note, it will not give you the same answer. The order matters. 99 times out of 100 will not give you the same answer. Only special functions give you the same answer, which we don't have here. So go through the process. Same thing. G is the outer function. F is the inner function. Plug in a -4. And so you start off by doing F of -4, take the output, and plug it in for G. So take a moment.
Is it 408?
I don't know. I don't know. So let's see. So we plug in -4 in for F first. That's the inner function. So that's 2 times -4 minus 1. That's -8 minus 1. So the output is -9. So we take that -9 and now we plug it into the G function. So negative 9 squared is 81. Now, continue forward. 5 times 81, 480, nope, 405. This is why you need to check your answer. Don't be shy about a calculator. And then, that's 408. Is that what you said?
Yep.
Okay, good. 408. That's the answer. So the composition is unique to functions. It's this is new stuff. But you have to translate it right. The first one is the outer function. The second one is the inner function. Take the value that you're given, plug it into the inner function first, find its output, take that output, plug it into the outer function. Just like, so you're doing a good job here. Whoever got 408, I didn't see. Is that Caitlin?
Yes, sir.
Questions? There's one more thing we can do with this, and you're not going to like it. But it's not something you've actually already done it before. You just didn't realize you've done it before. Now what we're going to do, we're still going to do F composed with G. That is not going to change. Instead, this input is going to be X. It still is the exact same process. Outer function F, inner function G. This time our input is an X, not a number. But it doesn't change the process. Doesn't change the process. What you're going to do is take G of X. And what's G of X in this case?
Five x squared plus 3.
5x squared plus 3. So we take that expression and you plug it in for, it becomes the input into the f function. It becomes the input into the f function. So look to the f function. Everywhere you see an x, replace it with what? 5x squared plus 3, whatever this is. So the output of G becomes the input of F, even if it's a formula, even if it's an expression. So 2 blank minus 1. That's where I have my X. Okay? That's where I have my... So in my blank, I put the 5x squared plus 3. And what I do here is I only simplify. I simplify the right-hand side. Combine like terms. Do whatever I need to do. The left hand, I don't care about that anymore. I just worry about that right-hand side. So what does that give us? Oops. So I multiply the 2 inside, and I get 10x squared plus 6 minus 1. Clean it up. Oops. Clean it up. 6 minus 1 is 5. There it is. This is the answer. 10x squared plus 5, I mean. So take the output of one function, make it the input of the other function. Guess what? You get to do this on your own now for a second.
Yay.
I want you to do G, or at least get started on G of f of x. So what's my outer function? How would I translate this?
Um, G of 5 times 2x minus 1 squared.
So I take f of x
Yeah.
and I make that the input into the g function. So it's 5 open parentheses 2x minus 1 close parentheses squared plus 3. Is that what you got, Addie?
Uh, yes.
Okay. Now what we do, we only simplify the right-hand side. Okay? Don't worry about that left g of 2x minus 1. There's nothing. You don't do anything with else. So we have to simplify this, which means we have to start by squaring that. Okay, so bear with me a second. So I'm just going to rewrite this because that's the input. So I got to square the 2x minus 1. What do I get? FOIL. When you do FOIL, you will get 4x squared minus 4x plus 1. I want to leave you to that to check. That's what you get when you get FOIL. Now, multiply that 5 inside. Bring down that 3. And then finish by combining any like terms. This, that's the answer. 20x squared minus 20x plus 8. Notice how it's completely different depending on which one's the inner function and which one's the outer function. So that's what you have to be clear on the translation on. Okay, questions on this? It just takes a little practice more than anything. Okay. I'm gonna move away from this. It's gonna all disappear, just to give you a heads up.
Can you hold for just a second? Sorry, it's kind of hard to write and listen at the time.
But just to keep one thing to sort of note here is when we're doing this, we're just simplifying the expression on the right hand side, getting rid of the exponent, getting rid of the parentheses, and combining like terms. That's what we mean by that. And it goes back to those lessons we did previously on polynomials, squares, FOIL, combining like terms. It just all it comes back into play here.
So the answer for that one is 20x squared minus 20x plus 8.
That's it. Yep. And so essentially this really does show you we are creating new functions. We're combining functions, creating new ones. So anyhow. Okay, so let me go back to one more thing before while we got just a few minutes. We're not going to get too far into it. We can do it tomorrow. Where are we at? Share screen. There we go. So I didn't get we didn't get as far as I wanted, but that's okay because this one's not going to be too terrible to do. The next lesson, at least, won't be too terrible to do. Where are we at? Inverses. Inverses. So when we talk about inverse in mathematics, we usually talk about the reverse process. Basically, you can invert something by flipping it over or invert it by going in the reverse direction. That's essentially what we're talking about here when we say inverses. So before we begin, remember one of the things we talked about early on when we're dealing with functions. We had this example here. We wrote functions like this. So 1, 2, 3. So that's the domain. And remember the range, we had something like this. Let me do it. So let's suppose we have A and B. And we said, okay, the 1 pairs with A, the 2 pairs with B, and I'm going to say the 3 also pairs with A. Is that a function? Yes or no, from your experience?
No.
What's the definition of a function? Every domain is paired with only one value in the range.
Yeah.
Do we have that here?
No.
We do, actually. The 1, how many pairs does the 1 have?
1.
Just 1. How many pairs does the 2 have?
1.
How many pairs does the 3 have?
1.
It's okay that 2 of them are paired to A. That's fine. But we look at the domain and ask ourselves, do each one of these have only one pair, one partner? And the answer is yes. So this is a function. Are we good on that?
Yeah, the trick is just remembering it, that the domain has to have one
The
pair, but
domain can only be
range,
paired with one member in the range. But it's
right.
okay. It's okay for the range to have multiple pairs, to have multiple domain values attached to it. That's okay. Think about parents to a children. 2 parents are paired with 1 child. There's
Right.
only 1 parent of each, uh, but they're both paired to the same kid. Okay, it's the same idea there. So kind of that's why I did it like that.
Okay, so in this example, so the parents are the
1, 2,
domain.
3. Yeah, the domain.
Okay, and the children are the range. Okay, I just need to make that straight so that I don't forget and mix that up.
Okay. This is going to really blow you away. Inverse looks at it the other direction. The other direction. So when we say inverses of functions, the starting point is that we're dealing with a function. Remember this test here, when we first started this, was to differentiate between relations and those special type of relations we call functions. Everything can be a relation. You can pair up anything in any way in any combination you want. But functions are only those special types of relations where each domain is paired with only one value in the range. Okay, functions is a special type of relation. So we're going to look at functions now and say, hey, some functions are so special they also have inverses. You can go backwards in them. You can go upstream. You can go in the reverse direction. But not all functions have inverses. Only very special functions. And only those functions that we say are what we call one-to-one functions. Let me say it this way. Only one-to-one functions have inverses. What does it mean to be one-to-one? That's the question, isn't it? So a one-to-one function is when each member of the range is paired with only one member of the domain. Okay, in a regular generic function, domain has only one pair in the range. It's okay if the range has multiple pairs. We don't care about that. This is just to identify whether we have a function. But when you're dealing with functions, only special functions have have inverses, it's when the range also only has one pair. Okay? So when you're dealing with one-to-one functions, it's actually the thing you really want. One domain to one range, and that is it. They're not paired with anything else or anybody else. So this thing here, this example I have on the screen, would not be one-to-one and would not have an inverse because the A kills it this time. It's still a function, it just is not a one-to-one special type of function. Cool? So how can we make this, how can we turn this into a function? I'm sorry, a one-to-one function. Well, still, is it a function? Every member of the domain has one pair in the range. Now ask the same question in the reverse. Does each member of the range have one pair in the domain? Yes. So this one we say is one-to-one, a one-to-one pairing. There's only one match for each. It's the thing you're probably typically looking for. If your function has, the cool part about this, in a one-to-one function, the domain and the range, to find the inverse, you just switch the domain and the range with each other. That's it. Because they're one-to-one, you can reverse them around. We'll talk about that tomorrow. But the essence here is, remember the procedure. We identified functions separate from relations, these special things called functions. Every member of the domain is paired with one member of the range. Now we're looking at special functions called one-to-one functions. These are functions, meaning one member of the domain is paired with one value in the range, but each value of the range also is only paired with one value of the domain. That's what makes it special. Those are called one-to-one functions. And if you have a one-to-one function, then you have an inverse. You can find an inverse function. And the reason for an inverse is it allows you to go forwards and backwards. Why would you ever want to do that? Question, do you ever send an email? Because email is a perfect example of a one-to-one function. Or specifically, let me more specific, encrypted emails, Snapchats, things of that nature, anything you want privacy attached to it. Because when you send an encrypted email to anybody, you're encrypting it on your end and you're sending it over there. They're able to unlock it and send you the key back so you can unlock the reverse message. Cybersecurity it basically is built upon this idea of inverse functions, being able to have a unique pairing both ways. You can send a secret message, but you have to get that secret message back too. So cybersecurity, any sort of cryptography, think back to World War II when they were the Nazis and the Americans were trying to figure each other's codes out, things of that nature. So cryptography is a perfect example of inverse functions. You can send a message, but you got to get the message back too. And that's the function, the way that you do that is an inverse function. We'll talk more about the mechanics tomorrow, but that's just wanted to mention this idea of what is an inverse. That's a one-to-one function, and if you have a one-to-one function, you can find the inverse as well. Questions on anything so far? Because I catch you over, so we're done, is what I'm saying.
I don't even know if I'd know where to begin with the question.
No, that's fine. Yeah, we haven't really dug into it yet.
Okay.
But I just want you to. We're connecting it back to this idea of functions. What does it mean? How do the two connect? We'll talk more about this tomorrow. But play with the other thing. Go back to play with the operation, the combining of functions. Add, subtract, multiply, divide, and composition. That's the big deal for tonight. That's the big deal. Where are we at? All the way down here. Yeah, that's the big deal. So play around with this. Due date's coming up Wednesday anyways, so that's going to be pretty good to get started on it. So get started on that, gather your questions. We can start talking about that too. Okay.
Thank you.
All righty. Well, hope you have a good one. We'll see each other tomorrow.
Thank you. Do you have
Okay.
a little time for questions or no?
What you got?
Okay. If everyone, needs to go, that's fine. But I guess it's mostly about my grade.
Oh, hold on.
If anyone else has
Let me,
any
let me
other
not,
questions,
let me
then they
not
can.
record, let me not record that then. Hold on.
Smart. Yeah. But if anyone else has any other questions first, that's fine. Or if you need to go.